Hey guys, Mr. Straub here. I just wanted to talk to you guys today about the lab that we've been working on and the idea behind it. So the purpose of the lab was to talk about physical changes, and we're going to be moving on to chemical changes. And so it's a good time to stop and pause and make sure that we can clarify the difference between a chemical and a physical change. And so that is what we're going to be taking a look at for this lesson. In general, we have a couple terms that we're going to talk about, and they showed up in the lab. The idea of a physical property, and this is generally a characteristic of matter that can be seen through direct observation. So something you can actually look at and measure. Things like density, melting point, boiling point, color, texture, all of those things would be physical properties. When you've changed something physically, you've acted on that substance, but you actually haven't changed the material. And so that was an important part of the lab that we did. The idea of doing this lab and then putting it back in the container so that we could use it again next year means that everything we did was a physical change. We didn't actually do any chemistry in this lab. And that's an important detail about the lab, is that this was a physical change lab. And so when we're going on to our next labs of chemical change, we'll realize that we can't reuse those substances. We've changed them into something different. And so the big difference between the physical change and the chemical change is a physical change, you could reuse it. It might be smaller, it might be bigger, but it is still the same stuff. Some examples of physical changes: melting, boiling, breaking, evaporating, like we saw in the lab. The one that's generally a little bit tricky for people and that tends to throw people off is the idea of dissolving. And that would be what we did in the lab, where we took water and salt, mixed them together, and it seems like we've changed it, but really we've made a solution, and we can get that salt, or in this case, the sugar, back. And so those are all physical changes, something that you can physically undo without any chemistry involved. We're going to be moving on to in the next lab is the idea of chemical changes. And a chemical change or chemical property is a characteristic of matter that can only be observed when one substance changes into a different substance, such as iron into rust. And so we have to understand the chemical changes, we actually have to mix things together and see what happens. Does it react with oxygen? Does it react with water? Does it react with hydrochloric acid? And those are chemical properties. What kind of reaction are we going to observe? In general, when you're talking about chemical changes, it's a transfer from one type of compound or one type of matter, and it's going to have different properties. And so you're going to break chemical bonds, put things back together, and in the process of doing that, give that compound new properties. Some examples of chemical changes are rusting, burning, your bananas even turning brown. General things that you're looking for when you're seeing a chemical change. Bubbles getting released is a good one. Example, like baking soda and vinegar, those bubbles are a good indication that chemical change has happened. Sometimes you'll see something that's called a precipitation. You might see the substance that you're looking at turn cloudy. You might feel a temperature change, either when you mix them together, things get hotter or colder. You also might see a color change or some type of new odor given off as well. So those are all possible. Light is another one. If you do see light, obviously it's an indication that there's some type of chemical reaction going on. And so here are a couple ones that we could take a look at. So pause the video and you can take a look at each of these, and I'll tell you if they are a physical or chemical change. So looking here at fireworks, think about, is that a chemical or is that a physical change? You've had a chance to think about these. The fireworks, since you're seeing light and hearing sound, that is an indication that there is a compound that is being formed in there. This is a chemical change. So this is, go ahead and pause the video. This is condensation here. Is that a physical or a chemical change? And condensation is a physical change. It's going from water in the air to water on a glass. Breaking a plate. Go ahead and pause. That is a physical change. You're just making the plate smaller. It's still a plate. Plant material, fruits getting brown is a chemical change. It's getting exposed to oxygen and oxidizing is what's actually going on there. So it's kind of similar to rusting on iron. So this is a fire burning. Is that a chemical or physical change? So combustion or burning, that is a chemical change. You're not going to get those trees back at the end of the forest fire. This is boiling water. Is that a physical or chemical change? That is a physical change. Your water is bubbling, but it's going into the air. You could have something cold up here and it would hit that and then turn right back into liquid water. This is an ice storm. That ice forming there, is that a physical or a chemical change? That is, of course, a physical change. Once it warms up, that ice will melt, and you'll no longer have that ice there, but you can get it back. Cooking. So this is a nice steak. Well done. And is cooking a physical or chemical change? This is a chemical change. You cannot uncook your meat. Once it's been seared brown on the outside, you're not going to get that back to the pink. And so that is a chemical change. A lot of cooking is chemical changes. Another example here, baking bread. Is that a chemical or physical change? And baking bread is a chemical change. Again, because you are, once you're baking this, you're not going to be able to unbake it. There's some interesting chemistry that's going on there with the yeast and the sugars. But that is a chemical change. Chewing. So if you bake that bread and you start to chew it, is that going to be a physical or a chemical change? And actually, the first bite is going to be a physical change. You're just making the bread smaller. Now, once that bread goes into your stomach and you start to swallow it, will that be a chemical or a physical change? Turns out that this is now going to be a chemical change. While you've made the bread smaller in your mouth by chewing, pretty quickly chemistry takes over. There's actually some enzymes in your mouth and in your stomach that are going to start breaking that bread down into chemically smaller things so that you can turn them into you. And so that right there is a chemical change. Digestion is a chemical change. You're not going to get bread back. This is dry ice sitting in a container. So it's frozen carbon dioxide. And is that are we witnessing, is it bubbling here? Is that a chemical or physical change? This is a physical change. This is dry ice sublimating, going from a solid to a gas. Iron rusting. That is a chemical change. And that is it for our chemical and physical changes. After you guys finish watching this video, there's a Google form just below to go over the difference between chemical and physical changes. Make sure that you know the difference between an element, a compound, and a mixture. Good luck, guys.